Hello. An important skill that we need to know for data science and even more importantly data engineering is Linux and how to use it, what it's all about. This is one of the major learning objectives of this course, in fact, is to learn how to use Linux and what the different types and options are. So Linux, this is an operating system that has many different flavors or varieties, and so if you do some Google searching or look at the list of Linux distributions, there's actually hundreds of them, but they kind of fall in a few of these different categories. So we won't go into all the different categories, but we'll just look at a few of the top ones. If you search through different articles about the top Linux distributions, Ubuntu is pretty much coming out on top on all of these. So for beginners, Ubuntu's listed top, general distribution listed top. For servers, it's listed as top. The number of images on AWS, Ubuntu outnumbers all of the rest of them. And also in terms of Google Trends and Google searches, Ubuntu is the most searched for distribution on Google. So what this means is that if you're starting out with Linux, it's probably best at this moment to start by learning Ubuntu. There's some other distributions as well that are important to know about, at least. There's Debian, there's Red Hat variants, which includes CentOS, and then there's also SUSE. So those are some other ones just to be aware of. But in general, Ubuntu and Red Hat varieties are probably the most used. These all kind of have a common look and feel, and in general we're interacting with Linux through a command line or terminal like this. So if you're running a Linux operating system, you'll probably have an access to a terminal. So maybe the easiest way to play around with it is just to go to Google Cloud and spin up an Ubuntu virtual machine and just play around with that. So let me do that really quickly. So again, we're going to our menu, compute engine, VM instances. We have to have our project chosen, which you should have your credits and billing linked to and have a billing alert set up so that we don't use too much. And I left one on overnight, I guess, which is kind of funny. But I'm going to create one here. I'm going to use the Iowa region. I'm just going to use 2 virtual CPUs, 7.5 gigabytes of memory. I'm going to change the image to Ubuntu 18.04. This is the latest so-called long-term stability, LTS, which means the Ubuntu organization has committed to supporting it with updates for at least 3 years. So I'm going to choose that one. I'll just leave it at 10 gigabytes. We don't need anything big. And I'm just going to leave everything else default. So Ubuntu 18 is our image with 10 gigabytes. If you left it on for an entire month, it'd be $50, but we're only going to use it for a short time. So I'm going to go ahead and create that. And I'm going to delete my other one, which somehow did not get shut down. While we're waiting for that, we'll take a look at some of the commands. So Linux has a set of basic commands which are universal across these different operating systems. And the first thing to know is how to navigate the file system. So the file system being how we're storing all our data in the operating system. Okay, so this formatting's a little off. So we have these different commands which we're going to go through. I'm just fixing the formatting so it's easier to look at. So let's start with one to just show where we are in the file system, which is print working directory, PWD. So again, we click on this SSH button, for our instance, and it just drops us into a terminal. One thing about Linux is it's used for servers a lot, and servers might be remotely located or might not have a GUI, graphical user interface built with them, so you might have to interact with them via these terminals. So if we're in got too many terminals open on my computer here, but if we're in a terminal and we do pwd, it shows us our working directory that we're currently in. So here we go, we've got our instance up now. pwd shows us in our home directory. Some other important ones, ls, we can list the files. So let me actually create one here, just so it shows something. So touch is another little one to just create a file, but ls will list the files in a directory. And then ls, you can add some options with a dash, and -l will show a bunch more details, which we'll get into a little bit later. So some other important ones are cd for change directory, rm for remove or delete, and then mkdir, which is make a directory. So let's play around with those. cd ... will move us up one directory. So now we can see we're in this home directory. If we do cd ... again, now we're just in the very base directory of the entire operating system and file system, which is just a /. Now if we do ls, we're going to see a bunch of different files in here which have to do a lot with the operating system and different executables in our operating system. We can also see our home directory there, so if we want to go back into our home directory, cd home ls to see what's there, and then I'm going to change back into my own home directory. So that's how we can move around the file system with cd, and look where we are with pwd, and then list files with ls. So some other ones, let's start with the mkdir. So we already saw how we can use touch to make a file. So I just created this empty file with touch, and let's say we want to delete that file, we can use our rm for remove and delete it. And now it's gone. So there's no recovery of these deleted files when you use the rm in Linux, so you have to be a little more careful than maybe in Mac or Windows where you can undo a delete. The other thing, so we can make a directory. Let's make a directory. So we can see when we list the files and directories, our directory is a different color than a file. And then we can also change directory into it. And then we can change back out of it. And now if we want to remove that directory, rm doesn't work because it's a directory. Rm is only for files, so we have to give rm an option -r. So we provide options to commands with a dash symbol and then a letter, and then we can remove the directory. This R usually, I think, stands for recursive, which means it goes into the directory and just keeps going all the way into the directory, and will remove everything in that folder. So now that folder is gone, and so that's how we can make folders, remove them, remove files, and make files. Another couple important things to know are sudo, and this, we'll get into this in a little bit, but it's like running files as an administrator, or running commands as an administrator in Windows or Mac. An important thing to do is also to be able to get help on commands if we don't know what they're doing. So there's the man command, which is for the manual. I think Ubuntu 18 might, it's working now. Sometimes, at least my local installation of Ubuntu 18 is a little buggy with the man command, but at any rate, it shows the name of the command, what it means, shows how to use it, and then it gives all these different options that we can provide to the command. And we can use the arrow keys to scroll down, and then the Q key to quit. So that's how to get help. Also, if we go and want to Google something, can also use something like man ls Linux to search for a command. And it'll also bring up a couple different websites which just have stored the manual pages completely online. So that's another option for getting help with commands. A few other useful commands to know are which. That shows where something is located. So for example, if Python is installed, we can do which Python, and then it shows the path to where Python is. I don't know if Python is installed here. It doesn't look like it is, so it just returns nothing when we look for it. A few other commands, just a few other small ones, and in fact the formatting again is a little screwed up. So which, where is a very similar command to which. There's echo, which we'll get to in a second, and then commands for logging out, rebooting, and so on. Okay, should have fixed it. So echo will print out whatever comes after echo. So, for example, just echoing the word tests works like that. We can use that to print out environment variables, which we'll get to in a little bit. Export is another command which has to do with environment variables. We'll get to that in a minute. Source will run a file. So if we have a file and we do source and then the file name, it'll run that file. We can use logout to log out of the session. If we do that in our terminal here, then it's going to close the terminal. We can also do shutdown, which shuts down the computer, and reboot, which restarts it. I believe that's the correct one. Yep. So then a few other things, chmod and chown changes the permissions, so read, write, and execute for files, and then chown changes the group and user ownership, which we'll get to in a second. So those are some basic commands. The most important ones are these file system navigation and creation modification type commands. So practice just kind of moving around the file system a little bit at first, looking at what's there. So if we want to change up to directories, we do cd ... ls to see what's here. Maybe let's go into the bin directory, see what's there. Quite a few things. So just play around with that, look at the file system, see what's there. These are mostly system files, but anyway, it's just good practice to know how to move around. So the next thing to know about is environment variables, and these store information for the operating system to use. So a simple example was that home environment variable that we just looked at. And as we saw, we can use echo $home in order to see what's in that environment variable. So that prints it out for us. And notice how we have this $sign and then the name of the environment variable. So if we want to look at it, we use echo. If we want to create a new environment variable or just set the value of one, we can use the export command. So let's use this export new var equals testing. So we exported this environment variable. Notice there's no $sign here when we're exporting it. And then if we look at what's in it, we've got $sign and then the environment variable name to be able to use it to print it out And so we can see it's been set to the value testing here. So if one doesn't exist, like let's just say something that doesn't exist, it's just going to print out nothing. So another important environment variable is this path environment variable. This is where the operating system will look for commands when we type them. So it's got file folders and directories, and Linux, usually this includes something like /user bin, which has a lot of our executable files. So so if we want to look at that environment variable, again, we just do echo $path, and we can see all the different places it's looking for commands. So we've got a folder here, then, oops, that's funny, folder, then a colon, another folder, colon, and there's our user bin right there. If we want to add a location to our path so that we can run something from that location easily, we can export the path to include a new file path, give it a colon, and then give it the existing path environment variable. And so now I just press the up arrow key a few times to get back to a previous command. Now when we look at that, we've tacked on user bin to the beginning of our path. So I'm trying to think of a simple command in this that we could run to. So even the ls command here is in the user bin, or is actually just in the bin folder. So using which ls shows us that command's in bin ls, and this. So let's see if just /bin is in our path, so it knows to look in bin when we type a command to see if we can find ls. So that can be pretty important to set the path so that certain programs work correctly. Another few things about it, there's usually this bashrc file, at least in Ubuntu Linux and some other types. So if we change directory to our home directory, and because it has a period before the name, it's actually a hidden file, so it doesn't show up when we do a regular ls. Let's see if we can figure out in the manual pages how to show hidden files. I'm guessing -h maybe? No, that's human readable. I think perhaps we give it 2 L's. Let's see here. So yeah, I'm not actually seeing it here, but I think if we do ls-ll, no. I'm not sure how to exactly show the hidden files off the top of my head, but this bashrc file is there, and this cat command will show us what's in it. So we can see it's got a bunch of things in it that are already in there from the operating system. The point of this is that we can add these environment variables, like say we want to add part of the path folder to the path. We can put that in bashrc or this other hidden file .profile, and those will be loaded when we create a new terminal or when we log in. So the bashrc file can be used to store some configurations for your system. So that reminds me, I'll have to add a few more commands in here. We've got there's cat, head, and tail. So tail looks at the last few lines of a file. So if we just want to look at the end of our bashrc file, we can use tail on it. If we just want to look at the top of it, we can use head on it. And there's an option for these to show number of lines. So maybe we just want to look at 2 lines, give it the option -n, and then 2, look at the top 2 lines. So those are a few other commands just for playing with files. Let me also add the touch command there. So those are some basic Linux commands. There's a ton more, but we're not going to get into them. So when we have these files and folders and we look at them with details, we see that this one, there's some different settings for read and write, and it also shows who owns it and what group owns it. So those 2 things are important because, for example, if we go into our bin directory, we can see that the root user owns all these other files, and these have an executable permission. So we can use these 2 commands, chown and chmod, to change ownership and permissions for executing and reading and writing files. It's not super important now, but it can be for certain applications. And so you'll also notice that these system files are owned by root. The root user is a universal user that's in most, or if not all, Linux distributions, and this root user has the power to do anything to the system. So delete any file, create any file anywhere, things like that. And so if we want to get administrative privileges and run things as the root user, we can use sudo to do something. So in this case, the way it's set up with our cloud computing resource, when we use sudo, it doesn't ask for our password. But if you were to install Ubuntu or another Linux locally, when you use sudo to do something, it asks for your password, and you have to enter it, and then it works. So it's just kind of a security thing for being able to run these commands as with full permissions. Okay, so that's kind of a brief overview of users and files and folder ownerships. The last thing is installing software. So these different Linux distributions will have different ways of installing software. Ubuntu and Debian are pretty similar. They use this aptitude package manager, and their files that you can, say, download from online to install usually end in .deb, which is similar to .exe files in Windows, or .pkg or .dmg files in Mac. So with our software in Ubuntu, oftentimes we want to update all of it, and one way to do that is to use this apt-get command, which is our package or software manager, and update. This update command is going to check for any updates to our software. So I'm going to run that here on the server on this virtual machine, and it's checking all these different websites, reading package lists to check which software has updates available. Then when we want to upgrade our current existing software, we can use the same sudo apt-get command and then upgrade. And so this is going to tell us some things. So it's going to say following packages will be upgraded, and gives us a list of all the packages that are going to be upgraded. And then it asks us, do you want to continue, yes or no? So I'll say yes, and we'll let that upgrade our software. And then if we want to install some new software, say we want to install Python, we can do sudo apt-get install Python. So once this finishes installing these things, I'll do that. It's taking a minute here. All right, so sudo apt-get install Python. So This is going to install Python 2.7. If we wanted to install Python 3, we would do install Python 3. I think, looks like it's already installed. So we've already got Python 3 installed, but if we wanted to install something new, we could do it like that. So, for example, the tmux program, if it's not already installed, we could install it like so. Another big distribution of Linux are these Red Hat type distributions. So CentOS is one of those, and they use a different package manager called yum. So instead of typing sudo apt-get, we would do sudo yum or just yum. And to update the software is a little simpler in CentOS or Red Hat. We just do yum update, and it updates our software that needs updating. And I've linked here to, let's see if that works. No, it's not working. It's probably going to crash my Chrome. But there is a list linked there of some other types of software and package managers in Linux, but we won't go over all of them because there's at least 6 different types. So that's kind of a brief introduction to Linux, and hopefully that gets you started. So practice a little bit with some of those commands. Go back, look at the file system, move around, make some files, make some folders, delete them. Use the manual to look up help for some of these commands. You can also do a lot of other things here. So there's a ton of other commands that can be done, and as you work more on Linux, you'll get more familiar with those. But for now, that's all we wanted to touch on. So we'll talk to you soon. Bye.